So now we look at lab 3.2 on network address translation. On network address translation, the objectives: number one, translation of address between networks, what we call NAT, network address translation. And also we're going to look at configuration of easy IP. So our topology looks like this. This is how our topology looks like. I have just implemented that on ENSP. And just to explain the scenario here, in this particular example, we're having two branch networks. We're having two branch networks. So we have this network. For example, this is the Nairobi branch, and this one here is the Kisumu branch. So what we want to do is to interconnect these two branch networks over the public network, which is the internet. Over the public network, which is the internet. So in order to be able to achieve that, we have to configure NATing. We have to configure NATing in our gateway, because within our internal network, we use private addresses. But for these packets to be routed on the external public network, they have to be NATed. They have to go out with a public IP address. So on R1 and R2, we are going to configure NATing. We have different types of NAT. In particular, on R1, we are going to configure dynamic NAT. On the other hand, on R3, we are going to configure easy IP. So that's the background to this particular scenario. Okay. So the very first step is about the basic configuration. This time I haven't done the basic configuration of the devices, so I'm just going to run through them quite fast. So I'm going to go and rename this to R1. I like renaming all the devices first before I do anything else. So to system view, then system name, this is R3. I also rename this to S1. System name to S2. Okay. So after we've done that, we can also configure the IP addresses. So for this one, we are supposed to configure G001. So IP address 10.0.1/24, and we're also supposed to configure int G0/0/0 with an IP address of public. Now this is a public IP address 119.84.111.1/24. So that's a public address. Okay, quit. We can also go to R3 and configure R3 interfaces. So on G002, on R3, we give it an IP address. Please make sure that your mic is muted. .324. We also go into G0/0/0 and configure an IP address on R3 119.84.111.3/24, like that. Okay, so once we've done that, on our switch, we are supposed to, just like the previous lab, we are supposed to create a VLAN. we're supposed to create a VLAN. So on step 1, we're supposed to create VLAN 4 on S1 and VLAN 6 on S2. We're also supposed to create VLAN interfaces, which now can be configured with these particular IP addresses. So let's go ahead and do exactly that. So on S1, we create VLAN 4. VLAN 4. We quit. Then we create interface VLAN if 4. Then we give it an IP address. IP address 10.0.4. As you can see from the topology, 254/24, like that. We can quit. Then we also go to S2. We do VLAN 6. We quit. Then interface VLAN if 6. We give it an IP address 10.0.6.254/24. Okay, so once we're done with that, what's the next step? So step 2 on cleaning up the previous configuration, we're not going to do that because we have begun with a new topology. So implement VLAN configuration for S1 and S2. So for that, we need to specify the particular interface that is connecting to the router as a trunk port and allow VLAN frames to be carried, and also allow all other frames to be carried as untagged frames, just like we did in the previous lab. Okay, so we do that. So let's begin from S1. Let me just clear this. You can actually do quit and do terminal monitor so that I don't get the feedbacks. Okay, so on S1, I'll go to this interface that connects to the router. Then I do the command to make it a trunk port. So port link type trunk, then port trunk PVID VLAN 4. Then we allow all other frames to pass as tagged frames. VLAN all. Good. So once you're done with that, we'll do display this. Display this to confirm. Okay. So everything is okay on that interface. So again, we go to this guy S2 and do the same. So the port that connects to the interface that connects to router 3 from S2 is G003. So we go there, 0/0/3. Then we do port link type trunk, then port trunk PVID VLAN 6. After that, we do port trunk allow pass VLAN all. So you can do display this to see. Okay. So indeed, we've made it a trunk port. PVID is 6, and we've allowed all the other frames to be able to pass through it. Okay. So once we've done that, we should be able to test the connectivity. We should be able to test the connectivity from R1 to the VLAN if of switch 1 and also from R1 to R3. They should be connected. So let's try that. So we want to test from R1. We ping this VLAN if interface on switch 1. So from here, R1, we do ping. Just want to move it so that I can see the IP address there. So 10.0.4.254. Good. So that should be successful. Then again, we ping R3 now. So ping 119.84.11.3. So it's also directly connected. So we should be able to ping it. So we've seen that so far R1 is able to ping R3 on this interface. It's also able to ping the VLAN if interface on switch 1. Okay. So let's go ahead and look at the next step. So step 4, configuring an access control list for R1 and R3. As we know, both dynamic and easy IP, NAT, network address translation, they depend on ACLs. So you have to create an ACL, do a rule that will permit packets from that particular network or from that particular IP. And then after doing the rule, now you can bind that ACL on that particular outbound interface, as we're going to do now on step 5. But on this particular step, let's begin with R1 and configure an ACL that will permit packets from 10.0.4.254 if they are going to R3. If they're going to R3 on that particular destination port, which is Telnet. Then we're also going to do rule 10, permit IP source. So anyone from this network, anyone from that network should be permitted. Destination any, if they're going to any destination. Then we have rule 15, deny IP. So that is it about R1. So let's go ahead and do it. So on R1, we go to system view. We go to system view and create SCL 3000. Then we create rule 5, permit TCP source 10.0.4.254 0.0.0, meaning it should match exactly as it is. If it's going to 119.84.111.3.3 0.0.0 on destination port equivalent to 23. So we've done rule 5, then we do rule 10. So permit IP source 10.0.4.0 0.0. We're simply allowing all packets from that network that goes to any destination. Any destination. Then we do rule 15, deny IP. So any other packet will be denied. Okay. Then we go and configure. This is an advanced ACL, as we already know. So on R3, easy IP, we want to configure a basic ACL on R3 to select the data flow whose source address is coming from the 6.0 network. So that's quite easy. So SCL 2000, or we have to go to system view. SCL 2000 Then rule permit. As you know, basic ACLs only permit or deny based on the source IP address header. So 0.0.0. So everyone from that network should be allowed. Good. So what 255 here? I'm just insisting again. 255 here means that this last octet can vary all the way from 1 to 254. This 0 here means this must be 10. This 0 here means this must be 0. This 0 here means this must be 6. But if you're having ones, 255 are ones, it means it can vary. This octet can vary. So make sure you remember that. Okay, so quit. Okay, so on step number 5, configure dynamic NAT. So we're also supposed to configure static route on S1 and S2 so that they can point to the gateway. So we configure static route on S1 and S2. So let's do that. So IP route static 0.0.0, 0.0.0. Then for this one, the gateway is that. Then we go to S2. We do IP route static 0.0.0, 0.0. Then we do 10.0.6.3. Okay. Okay, so once you do that, now we can configure dynamic NAT on R1. Dynamic NAT on R1. As you know, on dynamic NAT, you have a range. You have a pool of public addresses that can be mapped to your internal private IP addresses. So the first thing you have to do is to create that particular address group. That pool is created using the NAT address group command. So let's do exactly that on R1. So I'll quit. So the command is NAT address group. Then you give it an ID because you can have several address groups. Then you give it the start address range. So we want it to start from 240. From 240 all the way to 119.84.111.243. So here you have how many public addresses? 240, 241, 242, 243. So you have 4 public addresses that can be used. Then after that, you have to go into your interface. So 0, 0, 0, and now you apply that particular ACL. So here we created ACL 3000 and the address group 1. So you bind the ACL and the address group. So once you do that, then this will be able to, remember G00 is the outbound interface. This one, that is, so translation will occur here on this particular interface. So just before the packet exits to the public network, then NATing will be performed, as we are going to see in a short while. Okay, so what's the next thing? So we just want to configure R3 as a Telnet server so that we can be able to Telnet from R1 to R3, and therefore we be able to see the translation happening. Okay, so let's go ahead and configure R3 as a Telnet server. So R3, we have to enable Telnet server enable. Then we create user interface, VTY 0 to 4. The authentication mode, we want it to be password. So set please configure the login password. Please configure the login password. Okay, so let's do Huawei 123. Okay. Then we can quit. Let's see if we do set authentication password cipher. Huawei 123. Okay, I think we've already set the password there for the Telnet server. Okay, so what's the next thing? So we can do display NAT address group to see the address group that we've just created on R1. We should have done that earlier. Display NAT address group 1. So we can be able to see the start address 240, the end address 243. So these are public addresses that we have, a total of 4 public addresses. Okay. So now we can test connectivity. We can do a ping from S1 to router 3. So let's do that ping. So what you're simply doing, we are pinging R3 from S1. So from S1, we are pinging this guy. So that particular packet has to go to our gateway, get translated, go over the internet up to that particular guy. So that is what we want to see. Then we are going to observe how the translation happens on R1. So we come here, go to S1, and do a ping. We can ping even from that interface. So 119.84.111.3. So we can see that we are able to ping the external, the interface on R3. Okay. So establish a Telnet connection to the public address of the remote peer. So we've configured R3 as a Telnet server. So we want to Telnet from S1 to R3. Okay. So from S1 we do Telnet 119.84.111.3. We have to be on user view in order to do Telnet. Sorry about that. So I just did quit. You have to be on user view to Telnet or FTP. So the password is Huawei 123, and now you can see that we've gone into R3. We've gone into R3. So we are able to Telnet from S1 to R3. Okay, so let's check here. Do not exit the Telnet session. Instead, open a second session window to R1 and view the results of the ACL and NAT session translation. So On R1, we are going to type the command display SCL 3000. So on R1, we do display SCL, SCL 3000. So when you do display SCL 3000, we can be able to see haven't we had matches permit? Let me just confirm something here. Yeah, I was supposed to see at least one match for the permit because we've telneted to this particular network. I'm not seeing any match on R1. Why? I don't know why. I don't know why it's not displaying a match. It's supposed to be doing so. Let's go ahead and also do display NAT session all. NAT session table information. Does it take time? Something is not happening right on R1. Okay.
Use user view, not.
Yes. What are you saying?
Use user view.
Oh, I use. Okay. Okay. Thank you for that. Let's see. So display SCL 3000. Still does not indicate a match. It's supposed to indicate a match because we've telneted. Okay, let's try display NAT session all. Oh, sorry, I did server instead of session. Let's see. What we want to see is the source address, which will be the address on the VLAN if interface of S1, and the new source address, what it was translated to, the public address that it was translated to. That is really what we should see. Okay, good. So I think we can still be able to see it. The format is a little bit different on this NAT session table, but you see the source address indeed is the address on S1, on the VLAN if of S1. We can see that it's going to R3, and we can see that that particular private address is actually translated. This address is translated to this public address. So from private to public when we are going to R3. So we can say that indeed 242 is within the range that we created. Is within the range that we created in our NAT address group. So really, that is one of the things that we were supposed to emphasize and be able to see. Okay, so what else? Let's move on and look at the next instruction.
Jakaris.
Yes.
Now on this, it's dynamic, which means when the next, if you do another session, it should also change. Is it? Or we are, because if it's a dynamic nothing,
then
if we do another,
if we have another VLAN if we have another VLAN if interface with a private IP,
yes,
if we telnet to R3,
Yes.
it will be mapped to a different public, to a different public address. Dynamic NAT makes the assumption that not all your internal devices will want to access the public network at the same time. So you can have a fewer number of public addresses compared to the internal private addresses. Yeah, so if we have
now,
another...
We said it's a max of 15, was it?
A maximum of 15 public addresses?
Internal, or public addresses, right?
No, I'm not sure. I'm not sure. I cannot remember.
The one you're saying, the VTY 0 to 4, what was it?
That was the number of interfaces. The number of interfaces that you can get when you telnet to a device. You see here we've created VTY 0 to 4. So that gives us 5 interfaces.
Yes.
But that can be extended to 15. 0 to 15, which will give you 16 interfaces.
So like this address 10.0.4.254 can have a range of from a range of 16 public, which can be NATed to that address, right? My understanding.
I think you are mixing up two different concepts. You are mixing up NATing with the concept of Telnet and the number of interfaces that you can get. You see, you remember when we talked of the number of interfaces, we talked of the 2 types of interfaces that you can get, that VRP can give you. The first one is the console interface.
Yes.
When you connect directly using a console cable to your switch or your router, you only get one interface. No one else can connect to the same switch and get an interface where they can configure. But the second type of interface that VRP offers you is what we call the virtual teletype interface, VTY. And most of the time, you access VTY through Telnet. When you access your device through Telnet, then you get a VTY interface. So VTY interface ndio tulisema watu kadhaa wanaweza access the same device at the same time using a maximum of that particular number of VTY interfaces, 16.
Yes.
So that is it about the interfaces. So that has nothing to do with NATing. NATing is simply you have a range of public addresses that can be able to be translated and mapped to your internal private addresses when those packets are going to the internet.
Okay, thank you. Thank you, sir.
Okay, Kimtai, you raised your hand.
Karis, I wanted to understand when a device is connected to maybe a VPN network.
When a device is connected
to a VPN network, so you can also access it remotely, maybe through some equipment called microtics and
yes.
So,
yes.
But now, how does it now relate to telnetting?
You see, Telnet is the underlying protocol.
Okay.
Is the underlying protocol that is supporting you to access that device remotely.
Okay.
Yeah, so as long as the device is reachable and you've configured it as a Telnet server, then you can be able to Telnet to that device, whether it's via VPN or via the public network, or from within your local network.
Okay.
Okay, so
basically, telnetting is the protocol.
Yes, telnetting is the protocol that enables you to access devices privately, remotely, sorry.
Okay.
Okay, so let's move on. So here they're saying the ICMP session has a lifetime of only 20 seconds and therefore may not appear to be present when displaying the NAT session results, what we just did. So the following command can be used in this case to extend the period over which the ICMP results are maintained. If we wanted to extend the period over which this particular session information, this one here, is kept, then we can use that particular command. Firewall NAT session ICMP aging time 300. So that will give us 300 seconds instead of only 20. We really don't need to do that at the moment. Okay, so now on R3, we are supposed to configure EasyIP. So we configure EasyIP on that particular interface on R3, associating the EasyIP configuration with the SCL that had been configured earlier. We created SCL 2000 on R3. So how to do that? We're only supposed to do the command NAT outbound 2000. So when we apply that SCL, to the outbound interface, then it's going to know that this one is supposed to use EasyIP. So with EasyIP, all internal hosts are going to be mapped to the same public address, with the difference being the port numbers. So I hope you also remember that from the theory class. Okay, so on R3, we can actually check display SCL 2000. So you can see on SCL 2000, we are simply permitting any packet that is coming from that network should be permitted. So that is what we have on SCL 2000. So let's go ahead and go to that particular outbound interface, G0/0/0. Then we do NAT outbound 2000. So once we do that, it will know that the translation, this is how we configure EasyIP. So now the next thing we need to do is to test the connectivity between S2 and R1. So from S2 we ping, from S2 here, we ping R1. So ping 119.884.111.1. So we should be able, we should be able to ping it. And now if we check here, on display NAT session, if we do display NAT session all, let's do all on R3, we want to see how that ping was translated. So let's just see. As that loads, we can check if we have any other okay. Display NAT outbound SCL 2000. So we can also try out this command to see what we have. Okay, so it seems EasyIP does not use the session table. So let's use the command display NAT outbound SCL 2000. Okay, so we can see that the address group is a single public address and the type is EasyIP. So every other internal device is going to be mapped to the same public address, with the only difference being the port numbers. So if we made R1, for example, a Telnet server, maybe this particular command would have worked, and we would have seen that particular translation. So that is it about this particular lab. Does anyone have a question or a comment?